When two AI governance frameworks are compared side by side, the instinct is to ask which one is better. But the more important question is, are they even solving the same problem? The answer, in the case of LifeStack and ACRE, is no. ACRE, the admissibility and constraint for robustness and execution framework, is a substrate-centered admissibility model. It asks, is this state transition physically valid? LifeStack asks a fundamentally different question. Is this agent authorized to act, and can that authorization be cryptographically proven? These are different architectural problem classes. LifeStack spans the full stack: substrate, governance, execution boundary, provenance, and continuity. ACRE centers on substrate-level admissibility of state transitions. LifeStack's primary domain is agentic systems: identity, consent, governance, and execution control. ACRE's primary domain is deterministic admissibility of state transitions. One governs the agent. The other governs the physics of the environment the agent operates in. At the mathematical core, LifeStack defines an agent as the triple of codons, kernel, and phylatus coherence field. ACRE's minimal ontological identity is a matter-to-energy ratio. LifeStack's substrate is semantic cryptographic, meaning identity is encoded in meaning-bearing structures, not just physical invariance. ACRE's substrate is physical admissibility. They begin from different primitives. This is where the divergence becomes commercially significant. LifeStack's identity model is persistent, non-replicable, and cryptographically anchored using RLWE hardness, a post-quantum standard. An agent cannot be cloned, impersonated, or silently replaced. ACRE does not foreground identity in the same operational sense. LifeStack's consent model uses codons, structured tuples of permissions, boundaries, and lineage, as composable governance objects. Consent is not a policy layer. It is a formal invariant of execution. LifeStack models authority binding as an invariant who may act under what conditions is encoded at the substrate level, not enforced post hoc. ACRE does not foreground authority in the same way. On evolution and drift, LifeStack includes a mutation repair operator algebra that constrains how an agent may adapt over time, ensuring bounded divergence from its admissible identity manifold. ACRE has no explicit learning model in its current framing. LifeStack treats semantic drift as a structural runtime issue, not a monitoring problem. Both frameworks value constrained execution, but they frame it differently. LifeStack uses non-bypassable governance gates. ACRE uses commit-gated execution. On long-horizon viability, LifeStack is explicitly designed for persistence across time and state. Identity continuity and memory integrity are architectural requirements. ACRE is not a continuity-first architecture in its current framing. For agentic systems operating across sessions, this distinction is foundational. At scale, LifeStack supports multi-agent coordination through codon treaties and coalition governance, a formal mechanism for agents to negotiate and enforce shared boundaries. ACRE does not state this as a primary focus. LifeStack embeds cryptographic guarantees, RLWE kernel, anti-clone proofs, directly into control and persistence. And it specifies 12 quantum algorithms across 3 functional classes: identity and geometry, cryptographic security, and governance and repair. These are not aspirational. They are formally specified subroutines with verifiable control objectives. LifeStack's governance scope covers identity, consent, provenance, continuity, and execution control. ACRE covers physical invariance and admissibility. On failure, LifeStack treats refusal as success. A governed agent that correctly declines an unauthorized action has performed exactly as designed. ACRE uses refuse and block semantics. Both value safe non-execution, but the framing differs. One is a governance outcome, the other is a control constraint. Finally, deployment target. LifeStack is designed for agentic AI, embodied systems, governed autonomous infrastructure, long-lived agents operating in high-stakes environments. ACRE targets tightly bounded control environments. The intended deployment contexts differ materially. These are not competing solutions to the same problem. They are architectures built for different classes of challenge. LifeStack is the governance layer for the agentic era.